Assalamualaikum warahmatullahi wabarakatuh and good day. So today we will learn chapter 4, function of random variables. So previously you have learned chapter 1, discrete random variables and their probability distribution. And then you have learned continuous random variables and their probability distribution. And then you have learned bivariate random variables. Okay, so today we are talking about function of random variables. That means we are still talking about random variables, but now we are talking about function of. Okay, that means you have certain function. For example, previously you have learned x, okay, y, and then you have bivariate x1, y1, okay, but now it's a function. So when we are talking about a function, for example, u equal with x plus y. So what is the function of random variables? Okay, so this is the expected outcome. By the end of this chapter, you should be able to first calculate probability distribution. Okay, you must know how to calculate the probability distribution for function of a random variables using three methods. Okay, we have distribution function method. Okay, this is one. And then you have transformation method. This is 2. And then last is moment generating function method. So basically number 3 ni you have learned previously. Okay, but now we use again, but now we are focused on function of random variable. And then the second objective is to understand and calculate the density function of order statistic. So order statistic is 1, 2, 3 and so on. Okay, so you have two objective only, okay, but the first one you have three methods to be learned. Okay, so this is the content of this chapter. So you have the probability distribution of a function random variable. So this one we introduce you what is the function of function of random variables. And then we have first method of distribution function, and then method of transformation, and then method of moment generative function. Last is order statistic. All right, so introduction. So this is the motivation of why you learn this chapter. Okay, so the objective of statistic is to make inference. Okay, if you remember in applied statistic, we also learned, or we also do hypothesis, or we also find confidence interval in order to make inferences. So similar for this one. Okay, the objective of statistic is to make inference about a population. Okay, usually we are talking about population lah. Okay, based on information contained in a sample taken from that population. So the objective is similar with previous topic, which is applied statistic. Okay, we want to make inference about population, but we use sample to do that. Okay, so the preceding chapters plays a role in the development of statistical inference. So what have you learned in chapter 1, chapter 2, chapter 3 is very important. Okay, you must understand chapter 1, 2, 3 in order for you to develop the statistical inference. And the objective of statistics as closely as the study of the distribution of function of random variables. So you clear random variables, you know, you have x, y, z, t. That's a random variables. Okay, let y is the number of head occurs. So that is random variables. Okay, but now it's not only random variable. It's a function of random variables. Okay, when we are talking about function, it's similar with something equation. All right, equation, function. And then to estimate population parameter. Okay, once we have population and then we have sample to be used, based on sample we can estimate the population parameters or to make decision about a population. Okay, a function of the n random observation that appear in a sample. All right, so that's the motivation on learning this chapter. So this is the illustration for this chapter. Okay, so look, consider the problem of estimating a population mean. Okay, so you know population mean is a mu. Okay, so, mu. Alright, so let y1, y2, y3 until yn. So you have n random sample of observation from the population. So this is what you have learned in applied statistics. Okay, you have population and then you take sample. So that sample is y1, y2 until yn. Then the sample mean is y bar. So how you get y bar? You have y1 plus y2 until yn divide by n. Or in other words, you have this equation. Okay, and then you have this to estimate the mu. Okay, mu is the population mean. So here, how good is this estimate? Okay, it depends upon the behavior of a random variables and their effect on the distribution of y bar. Okay, so that's why we learned this chapter. Okay, we want to estimate the population parameter by using this sample. So how good is this sample, or how good is the estimator? Okay, so a measure of goodness of an estimate is the error of estimation. Okay, so the difference between the estimate and the parameter estimated, when we are talking error of estimation, it's the difference between estimate and the parameter estimated. Okay, in our example, the difference of between y bar here, okay, it's not mu, y bar and mu. How is the difference? However, if we can determine the probability distribution of the estimator y bar, okay, it's more better lah. Okay, that's why in this chapter, we want to find the probability distribution of the estimator y bar. So in order to determine the probability distribution for a function of n random variables, we must find the joint probability distribution for the random variable themselves first. Okay, so here you must understand. Okay, we have random variables. So in previous, we have learned x is random variable, y is random variable. For example, I said y is the number of head occur. So y is a random variable. And then you have learned bivariate random variable, which is you have x, y, or you have y1, y2. Right? So this is the bivariate random variables. But now it's a function of n random variable. So in this case, you not only have one random variable, not only two random variable, but you have n random variable. So when you have n random variables, in this case, if we are talking about mean, so that's a function of random variables that we want to find the probability distribution. Okay, so that's why before we find that, we must find the joint probability distribution function for the random variables. So this is for assumption population are large and independent. Okay, let's say your random variables is assumed to be large population and it's independent. So now you must know, is it dependent or independent? So in this case, when our random variables is independent, so the joint probability function for y1, y2 until yn, all sample from the same population is given by this equation. Okay, so you can see that the first one is for discrete random variable and this one is for continuous random variable. Okay, so this is continuous. So you can see from the discrete random variable, in chapter 1 you learn the probability function is py1, py2, py3. Okay, but since we have n random variables, the joint probability function for independent random variables, you will times py1 times py2 until pyn. And then for continuous, you have f here, so fy1 times fy2 until fyn. Okay, this one when we are talking about our population are large and the random variables are independent each other. Okay, all right, so in order to find the probability distribution of a function of random variables, okay, there are three ways to find the probability distribution for a function random variables, and a fourth method for finding the joint distribution of several functions of random variable. So here I'll focus on three first. Okay, we have the first one, the method of distribution function, and then you have the method of transformation, and then next is the method of moment generating function. All right. So I will stop until here for this video. I will continue with the method of distribution function in the next video. Thank you, class.